Hello everyone. So in this video we're going to be talking about pH. So you need to be able to calculate pH and then understand how pH is related to the concentration of H3O plus or hydrogen ion. So let's just talk about a few vocabulary things before we go any further. You've probably heard about pH. pH is a scale that is used to measure acidity, and it is a logarithmic scale. So to calculate pH, you need to use logarithms. And we'll talk about that a little bit further on in this video. So it is a logarithmic scale used to measure acidity. And the acidity of a solution depends on the concentration of hydrogen ion, H plus, or hydronium ion, H3O plus. So for our purposes, we're going to say that these two ions are basically equal. What happens when an acid dissolves in water is it produces H plus, and then since there's a lot of water, we have H plus and water that combine to form H3O plus. So as soon as the H plus is produced, it generally kind of links onto a water molecule and forms H3O plus, which is called hydronium ion. It's a polyatomic ion. So we're going to use H plus and H3O plus interchangeably. And when you see either of them in brackets like this, it means concentration of. So we're going to say right here, brackets mean concentration of. And with pH and with the concentration of H3O plus, the higher the concentration, the more acidic. So higher H plus or H3O plus equals more acidic. Now, with the pH scale, the higher the concentration of H plus or H3O plus, the lower the pH is going to be. So on the pH scale, if we have a low pH, that means we have a high concentration of H plus or H3O plus. So we have a high acidity. And then we're going to be calculating pH a little bit later. So the equation that we use to calculate pH uses logarithms. So pH is equal to the negative log of H plus, or of course you could say it's equal to the negative log of H3O plus. All right. So let's jump into talking about the actual pH scale. So you've probably seen this before, but just as a reminder, 7 is neutral on the pH scale. So let's go ahead and label that. So 7 is neutral, that's an N there. And then above 7 is basic. And then 14 would be the most basic. So we start with neutral at 7, and then as we go up, it gets more and more basic. Below 7 is acidic. And as we go further and further down the scale, the pH gets more and more acidic. So 0 would be the most acidic. So to explore this a little further, let's answer some of these questions about pH. This says, as pH decreases by 1, how much does the concentration of H3O plus increase? So let's say we're going from a pH of 6 to a pH of 5. You might think that the concentration of H3O plus just increases by 1, but the pH scale, since it's a logarithmic scale, it's based on tens. So as we go down the pH scale, the concentration, the acidity, actually increases by 10. So we would say here it increases by 10. There are a couple other logarithmic scales that you might be familiar with. One of them is the Richter scale, which measures basically earthquake severity. So like an earthquake that's a 5 on the Richter scale would be 10 times as serious as an earthquake that's a 4, and 100 times as serious as an earthquake that's a 3. So pH is similar. This question, how will the acidity or concentration of H3O plus in a solution with a pH of 2 compared to a solution with a pH of 4? So 3 would be 10 times as acidic as 4, 2 would be 100 times as acidic. So the pH of 2 would be 100 times more acidic. Now this next question is kind of asking the opposite. It's saying, how will the acidity or concentration of H3O plus in a solution with a pH of 5 compared to a solution with a pH of 3? So here's our pH of 3. Now we're going up the scale. So we're gonna get like 10 times less acidic. So 4 would be 1/10 as acidic as 3. 5 would be 1/100th as acidic as 3. So it would be like 1/100th times, or 0.01 times as acidic. And that's if we're comparing pH of 5 to a pH of 3. So with these kinds of questions, you just have to be careful and really make sure you understand, are they asking you to go down the scale? Like in this one, they were asking us to compare pH of 2 to a pH of 4, so 2 is lower. Or are they asking you to compare something above? So this one, they were asking us to compare a pH of 5 to a pH of 3. So 5 is 1/100th times as acidic. Okay, last thing for this video, we want to be able to just actually calculate pH on a calculator. So all you need to do for this is use the equation for pH. So pH is the negative log of H plus. So let's just write that out here. pH equals negative log of H plus. So in this problem, it would be negative log of 2.7 times 10 to the negative 6th. So to put that on our calculator, we would just need to type negative and then log. So we've got negative log, and then we need to put 2.7, and then we want to use our exponent button, so second E. So 2.7E negative 6. We're going to get 5 point something. So our pH is going to be really close to the exponent of the 10. It's usually going to be a little bit lower. So since the exponent is 6, the pH is going to be 5 point something. So it looks like 5.57 would be the pH. All right, so that's how you calculate pH. And then again, the pH is related to the H3O plus. The higher the H3O plus, the lower the pH, and the pH, as the pH goes down by 1, the H3O plus increases by 10. So those are the things you need to understand for this section.